Plenum-rated cables are not required within individual dwelling units for low-voltage data, telecommunications, and broadband cabling in high-rise residential buildings, even if the building exceeds 5 stories. Plenum-rated cables are only required in areas where the space above the ceiling is used as a return air plenum. The National Electrical Code requires the use of plenum-rated cables in return air plenums because these areas are part of the heating, ventilation, and air conditioning system and can potentially spread smoke and fire throughout the building in the event of a fire. Since individual dwelling units typically do not have return air plenums, plenum-rated cables are not required within these spaces. Instead, standard polyvinyl chloride jacketed Category 5 enhanced and radio grade 6 cables can be used for low voltage cabling within the individual units of the high-rise residential project. These cables are suitable for use in non-plenum areas and meet the performance and safety requirements for residential applications. It is important to understand the specific requirements of the National Electrical Code and any local building codes that may apply to the project. The National Electrical Code, or NEC, is a widely adopted standard for electrical wiring and safety in the United States. It's important to remember that while the NEC provides a baseline for electrical safety, local jurisdictions may have their own amendments or additional requirements that must be followed. When it comes to cabling, the NEC addresses the types of cables that are permitted in different environments based on their fire resistance and smoke characteristics. This is where the distinction between plenum-rated and non-plenum-rated cables becomes significant. Firstly, let's define what a plenum is in the context of building construction. A plenum is a compartment or chamber to which one or more air ducts are connected, forming part of the air distribution system. This space is often above a suspended ceiling or below a raised floor and is used for the circulation of environmental air, either supply or return air. Because a plenum is used for air circulation, any materials within that space, including cables, can contribute to the spread of fire and smoke in the event of a fire. Plenum-rated cables are specifically designed to minimize this risk. These cables are constructed with materials that have low smoke and low flame characteristics. When exposed to fire, they produce very little smoke and do not readily propagate the flame. This helps to maintain visibility for occupants trying to evacuate and reduces the amount of toxic fumes released into the air. The NEC mandates the use of plenum-rated cables in plenum spaces to ensure a high level of safety. Now, let's consider non-plenum spaces. These are areas that are not used for air circulation, such as the inside of walls, conduit, or areas where the air is not actively circulated as part of the building's heating, ventilation, and air conditioning system. In these non-plenum spaces, non-plenum-rated cables are typically permitted. These cables are generally less expensive than plenum-rated cables as they do not require the same level of fire resistance and smoke reduction. However, it's important to note that even in non-plenum spaces, cables must still meet certain fire safety standards. The NEC specifies different types of cables for different applications, taking into account factors such as voltage, current, and the environment in which the cable will be installed. When selecting cables for a project, it's crucial to consult the NEC and any applicable local codes to ensure that the correct type of cable is used for each application. This will help to ensure the safety of the building and its occupants. In the case of a residential high-rise project, the question of whether to use plenum-rated or non-plenum-rated cables within individual dwelling units often arises. As mentioned earlier, if the space above the ceiling or below the floor within a dwelling unit is not used as a return air plenum, then plenum-rated cables are generally not required. Standard polyvinyl chloride jacketed cables, such as Category 5 enhanced and radio grade 6, can be used for low voltage data, telecommunications, and broadband cabling within these units. However, it's important to verify this with the local building inspector or authority having jurisdiction, or OJ, as they may have specific requirements or interpretations of the code. It's also worth noting that some project specifications may require the use of plenum-rated cables throughout the entire building, regardless of whether or not the space is a plenum. This is often done as a precautionary measure to simplify the installation process and ensure a consistent level of fire safety throughout the building. In such cases, the project specifications would take precedence over the minimum requirements of the NEC. To summarize, the decision of whether to use plenum-rated or non-plenum-rated cables depends on several factors, including the type of space, the local building codes, and the project specifications. It's always best to consult with a qualified electrical engineer or contractor to ensure that the correct type of cable is selected for each application. This will help to ensure the safety of the building and its occupants, as well as compliance with all applicable codes and regulations. In addition to the NEC, there are other standards and organizations that provide guidance on cable selection and installation. These include the Telecommunications Industry Association, or TIA, and the Electronic Industries Alliance, or IAR. The TIA and EIA develop standards for cabling systems, including performance specifications, installation practices, and testing procedures. These standards can be helpful in ensuring that the cabling system meets the needs of the application and performs reliably over time. When installing cables, it's important to follow the manufacturer's recommendations and best practices for cable handling, routing, and termination. This will help to prevent damage to the cables and ensure that they perform properly. It's also important to properly support and secure the cables to prevent them from sagging or becoming damaged over time. In addition to fire safety, there are other considerations to keep in mind when selecting cables. These include the cable's electrical characteristics, such as impedance, capacitance, and attenuation. These characteristics can affect the performance of the cabling system and should be taken into account when selecting cables for specific applications. For example, Category 5 enhanced cable is commonly used for data transmission in residential and commercial buildings. It is designed to support data rates of up to 1000 megabits per second or 1 gigabit per second over distances of up to 100 meters. Radio grade 6 cable is commonly used for cable television and satellite television signals. It is designed to provide good signal quality and minimize signal loss over long distances. When selecting cables, it's important to choose cables that meet the performance requirements of the application and are compatible with the other components of the cabling system. It's also important to consider the cable's environment and choose cables that are suitable for the temperature, humidity, and other environmental conditions in which they will be installed. In some cases, it may be necessary to use special cables that are designed to withstand extreme temperatures, moisture, or other environmental factors. Proper grounding and bonding are also essential for ensuring the safety and performance of the cabling system. Grounding and bonding help to protect against electrical shock and reduce the risk of electrical noise and interference. The NEC provides detailed requirements for grounding and bonding of electrical systems, including cabling systems. It's important to follow these requirements to ensure that the cabling system is properly grounded and bonded. Finally, it's important to test the cabling system after it has been installed to verify that it meets the performance requirements of the application. Cable testing can be performed using a variety of test equipment, such as cable analyzers and network testers. These testers can measure various parameters, such as cable length, signal loss, and crosstalk, to ensure that the cabling system is performing properly. In summary, selecting and installing cables requires careful consideration of various factors, including fire safety, electrical characteristics, environmental conditions, grounding and bonding, and testing. By following the NEC, industry standards, and best practices, it is possible to ensure that the cabling system is safe, reliable, and meets the needs of the application. Remember to always consult with a qualified electrical engineer or contractor for specific guidance on cable selection and installation. The information provided here is for general guidance only and should not be considered a substitute for professional advice. When working with electricity, it is important to take all necessary safety precautions to protect yourself and others from harm. Always de-energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember, safety is always the top priority when working with electricity. The use of appropriate cable management techniques is also essential for ensuring the long-term reliability and performance of the cabling system. Cable management involves organizing and routing cables in a neat and orderly manner to prevent tangling, kinking, and other forms of damage. Proper cable management can also make it easier to troubleshoot and maintain the cabling system over time. There are a variety of cable management products available, such as cable ties, cable trays, and cable raceways. These products can be used to support and protect cables, as well as to keep them organized and out of the way. When installing cables, it's important to avoid sharp ends or kinks, as these can damage the cable and reduce its performance. Cable should be routed in a way that minimizes stress and strain on the cable and its connectors. It's also important to avoid running cables near sources of heat, moisture, or other environmental hazards. In addition to physical cable management, it's also important to label cables properly. Cable labeling makes it easier to identify and trace cables, which can be helpful when troubleshooting or making changes to the cabling system. Cable labels should be clear, concise, and durable, and they should be attached to the cables in a way that is easy to read. There are a variety of cable labeling systems available, such as printable labels, adhesive labels, and heat shrink labels. The choice of labeling system will depend on the specific application and the environment in which the cables will be installed. Regular inspection and maintenance of the cabling system can help to identify and address potential problems before they become serious. Cables should be inspected periodically for signs of damage, such as cuts, abrasions, or corrosion. Connectors should be checked to ensure that they are securely attached and free from corrosion. If any problems are found, they should be repaired or replaced as soon as possible. In addition to physical inspection, it's also important to test the cabling system periodically to verify that it is still meeting the performance requirements of the application. Cable testing can help to identify weak spots in the cabling system and ensure that it is performing optimally. The frequency of cable testing will depend on the criticality of the cabling system and the environment in which it is installed. For critical applications such as data centers or hospitals, cable testing may be required on a regular basis. By following these cable management and maintenance practices, it is possible to ensure the long-term reliability and performance of the cabling system. This will help to minimize downtime, reduce costs, and improve the overall efficiency of the organization. In addition to the technical aspects of cable selection and installation, it's also important to consider the aesthetic aspects. In many cases, cables will be visible to occupants of the building, so it's important to choose cables that are visually appealing and blend in with the surrounding environment. There are a variety of cable colors and styles available, so it's possible to choose cables that complement the building's decor. It's also important to route cables in a way that is visually appealing and minimizes clutter. Cables should be hidden behind walls, ceilings, or floors whenever possible. If cables must be visible, they should be routed in a neat and orderly manner and secured with cable ties or other cable management products. The use of cable concealment products, such as cable raceways and cable covers, can also help to improve the appearance of the cabling system. These products can be used to hide cables and protect them from damage. In some cases, it may be necessary to paint cables to match the surrounding environment. However, it's important to use a paint that is compatible with the cable's jacket material and will not damage the cable. The NEC provides specific requirements for the types of paints that are permitted to be used on cables. The design and installation of a cabling system should be integrated with the overall design of the building. This will help to ensure that the cabling system meets the needs of the building and its occupants. The cabling system should be designed to accommodate future growth and changes. This will help to avoid the need for costly and disruptive upgrades in the future. The cabling system should be designed to be flexible and adaptable. This will allow it to be easily reconfigured to meet changing needs. By considering the aesthetic aspects of cable selection and installation, it is possible to create a cabling system that is both functional and visually appealing. This will help to improve the overall appearance of the building and enhance the user experience. When designing and installing a cabling system, it's important to consider the needs of all stakeholders, including building owners, tenants, and IT professionals. Building owners are concerned with the cost of the cabling system, its reliability, and its impact on the building's value. Tenants are concerned with the performance of the cabling system, its ease of use, and its aesthetics. IT professionals are concerned with the manageability of the cabling system, its security, and its ability to support future technologies. By considering the needs of all stakeholders, it is possible to design and install a cabling system that meets everyone's needs and expectations. This will help to ensure the long-term success of the project and the satisfaction of all involved. It is good practice to document the cabling system thoroughly. This documentation should include information about the cable types, cable routes, and termination points. The documentation should be kept up to date and readily accessible. Proper documentation can be invaluable when troubleshooting problems or making changes to the cabling system. It can also be helpful for future building occupants or IT professionals who may need to understand the cabling system. There are a variety of software tools available that can help with cable documentation. These tools can be used to create detailed diagrams of the cabling system and to track cable inventory and maintenance records. Investing in proper documentation tools and processes can save time and money in the long run. It's also important to train personnel on the proper use and maintenance of the cabling system. This training should cover topics such as cable handling, termination, testing, and troubleshooting. Properly trained personnel can help to prevent damage to the cabling system and to quickly resolve any problems that may arise. Training should be provided on a regular basis to ensure that personnel are up to date on the latest technologies and best practices. By investing in proper training, it is possible to improve the reliability and performance of the cabling system and to reduce the risk of costly downtime. Furthermore, consider the environmental impact of cabling choices. Opting for cables with recycled content or those that are easily recyclable at the end of their life cycle can contribute to a more sustainable building design. Work with suppliers who prioritize environmentally friendly manufacturing processes. Also, explore options for reducing cable waste during installation, such as accurate measurements and efficient cable management techniques. By considering the environmental impact of cabling choices, it is possible to reduce the building's carbon footprint and promote a more sustainable future. Finally, remember that building codes and industry standards are constantly evolving. It's important to stay up to date on the latest changes and to adapt cabling practices accordingly. Subscribe to industry publications, attend training courses, and participate in professional organizations. By staying informed, it is possible to ensure that cabling practices are always in compliance with the latest regulations and best practices. This will help to protect the building and its occupants, and to ensure the long-term reliability and performance of the cabling system.